Okay, so we're going to talk about squares and cubes and some rules of exponents. This is going to be, I think, a little bit shorter of a video. So anyway, let's start. So say we have a 2, and let's do 4 and 5, and let's also do 6, okay? Now, if we take them and we put a 2 on top of them right here, a small little 2, this is what's called a square, okay? We are squaring them. It's also, you can also call it 2 to the power of 2, 4 to the power of 2, and so forth and so forth. But you could also call it 2 squared, 4 squared, 5 squared, 6 squared, or some people also call it a perfect square, okay? And what does this mean? It's simple. All it means is 2 times 2, 4 times 4, 5 times 5, and 6 times 6, okay? Now, all you're going to do is do 2 times 2 is 4, and this is 16, this is 25, and this is 36, okay? Okay, so what we could do to maybe help you understand that a little better is, say you have a box, okay? And we're just going to do an example of 2 squared, okay? So let's say this right here is 2 inches. From here to here is 2 inches. And from here to here is 2 inches, okay? Well, that means that this is a perfect box, right? That there's 1 inch there, and then there's 1 inch there, and there's also 1 inch there, and there's 1 inch there, okay? Which means that you have 1, 2, 3, 4, and that's the area of that box, 4 inches, or 2 times 2 equals 4, all right? So let's look at something else. 4 times 4. So let's take a big 4. Okay, so we have, it's not perfect, right? It's not a perfect box, but it's okay, it's going to work. All right, so pretending this is, perfect square, you're going to have something like this, okay? So from here to here is going to be what? 4 inches, okay? And then from here to here, also 4 inches, okay? And then if this was a perfect box, this would be 1 inch, 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 so forth and so forth, okay? And if we add those all up, what do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is also 4 times 4, okay? So this is what we call a square, a perfect square. 4 squared is 16. 2 squared is 4. 5 squared is 25, and so forth and so forth, okay? All right, so that's squares. Let's go over cubes now, okay? So just 1 second. Let's erase this first, make some room. Okay. All right. So let's say that we have, let's just do it again, 2 and 3 and 4 and 5, okay? All right, and we're going to cube them, okay? So cubing means that we're just going to put a 3 up above. 3 and 3 and 3, okay? what that means is this. You're going to take 2, and you're going to do 2 times 2 times 2. And this is going to be 3, sorry. Times 3 times 3. This is 4 times 4 times 4. And this is 5 times 5 times 5, okay? Well, 2 times 2 is 4. Times 2 is 8. Let's get a different color there real quick. Let's use magenta. All right, so this is 8. And this is going to equal what? Well, 3 times 3 is 9. Times 3 is 27. And this is going to equal what? Well, 4 times 4 is 16. Times 4 is 64. And then 5 times 5 is 25. Times 5 is 125. Okay? All right. So that is cubing it. Okay, that's just the basics of cubing it. I'm not going to write out a box, and I'm not going to, show you with a diagram. That's just basically what it is. When you're cubing something, you're timesing it by itself 3 times. Okay, just remember that. Okay, so let's go over a rule when it comes to exponents. Okay, so let's say that you have. Let's say that we have 2 down here. We'll make it easy. 2. So 2, and let's say it's powered to the 7th power. And then we have another 2 right here. And it's powered to the 3rd power, okay? Now, when you timesing, right? When you have a product of powers like this, see? Right? When you have 2 bases that are the same, see this base is the same as this base, then what you can do is you can rewrite that as 2 to the power of 7 plus 3, which equals 10. So it would be 2 to the 10th power, okay? Now I could show you, I could prove that to you. Okay, so let's look at this real quick. So what does this represent? And what does this represent? Well, this represents 2 times 2 times 2 times 2 times 2 times 2 times 2, okay? See how tedious that is? That's why this is much easier. Anyway, 1, 2, 3, 4, 5, 6, 7, and then that right there represents 2 times 2 times 2, okay? Well, we already know what this equals. We already did that a second ago. It equals 8. So let's do that then. This is going to be 8 right here. If I cut that off, and then this is going to be 8 right here. And this right here is just 2. So 8 times 8 is what? 64. If you remember your times tables, and then we times that by 2. So let's times it by 2. And that equals 8. And that equals what? Right there. 128. So then we're going to times that by what? By 8. Okay. So 1, 2, 8. 8. It's going to be 4. 64. And then we're going to put the 6 up above the 2. And then this times 2 times 8 is what? 16 plus 6 is 22. Put that there. Put the 2 up there. And it's going to be 1,000. Let's rewrite that because that 4 is a little screwed up. It's going to be 1,024. Okay? Now, I'm going to verify with my calculator that I'm right. So let's look at that real quick. 2 to the 10th power is exactly that. It is this number, 1,024. Now if I want to use something a little bit more simple, even simpler than that, let's just do 3 to the power of 2 times 3 to the power of 2, okay? Which we know from before that is really 3 to the power of 2 plus 2, which equals 4, 3 to the 4th power, okay? Well, 2 to the power of 2 is what, 9? And 2 to the power of 2, 3 to the power of 2, sorry, is another 9. And 9 times 9 is 81, okay? All right, or we could write it out. 3 times 3 times 3 times 3, okay? So this times this is 9. And then we take a 3 down, and that equals 27. Then we take another 3 down, and that's going to equal 81. I'll prove it to you right here. 27 times 3, that's going to equal 21. Put the 2 up above. This times this is 6, plus 2 is 81. So anyway, that's just showing you that it's true. If you take two numbers, right, two numbers in exponential form, if the bases are the same, this is the base, right? If the base is the same as this base, then what you do when you times them together is you're going to add the exponents up above, and instead of being 3 squared times 3 squared, it turns into 3 to the power of 4. Okay? So that's one rule that we need to memorize, okay? Then I'll write another rule out for you. Make some room for this. Okay. Now this may be something that you're just going to have to memorize, okay? You are. Just memorize this, okay? So say you have 10 or 20, or let's say you had 1,000, okay? Or 2. If you have any of those numbers and you take those numbers and you power them to the power of 0, all of them, every one, is going to equal 1. So that's 1, that's 1, that's 1, and that's 1. Just memorize that, okay? It's a rule, and it always applies, and just memorize it. And I guess the way we could show that to you is, if you remember, we had that 3 squared times 3 squared, okay? What does that equal? Well, that's going to equal 3 to the power of 4, okay? Well, and why is that? Well, the reason that is because you have that 2 plus 2 of these two numbers, okay? But let's just say we had something like 2 to the power of 6 times 2 to the power of 0, okay? What does that equal? Well, that equals 2 to the power of 6 plus 0. All right, so basically this just kind of disappears because it's no longer counted, okay? Because 6 plus 0 is still going to be 6, so it's 2 to the power of 6. So 2 to the power of 6 times 2 to the power of 0 just turns into 2 to the power of 6. All right, so basically what it's saying is it's 1, because 2 to the power of 6 times 1 is still going to be 2 to the power of 6. Does that make sense? Anyway, that's the best way to explain it. That's why any number to the power of 0 is going to equal 1, okay? All right. All right, well that pretty much is it for what I want to show you about exponents. There's other rules, but we're not going to go over those today on this video. We're gonna go over those rules later on, and that's it.